Hey everyone, this is AWS On Air, the Startup Spotlight. And my name is Jillian Ford. I'm a startup solutions architect at AWS. And I'm here with a host is Chad.
Hey everybody, my name is Chad Lacey. I'm a global sales strategist at AWS on our field enablement team. And go
Our
ahead, Jillian.
amazing, yeah, awesome. Our amazing guest today here is Robert, who is the CEO and co-founder of Anyscale. So yeah, Robert, introduce yourself to all of our friends here who are watching.
Awesome, thank you. So I'm Robert, one of the co-founders and CEO of Anyscale, and we are building a platform for distributed computing and building scalable applications, especially scalable AI applications. And we're commercializing Ray, which is an open source project for distributed computing. So super excited to be here.
Robert, welcome. We appreciate having you here. Lots to dig in there too. Just want to see if maybe you could take a step back and tell us a little bit about why you created Ray, the problems it solved, and maybe the differences between Anyscale and Ray.
Yeah, absolutely. So my background, how we got started with this, I was doing a PhD in machine learning at Berkeley. Super excited. We were trying to design better algorithms for optimization, for deep learning, reinforcement learning, a lot of really cutting edge machine learning work. And one of the challenges that I encountered, and it wasn't just me, but really all of us, one of the challenges we encountered was that even though we wanted to spend our time designing algorithms and thinking about better ways to do AI, where we were actually spending our time was building infrastructure, doing the engineering work to scale our applications, to make our applications run faster. And that was a surprise to me, right? Because it felt like one of the main things holding back progress in machine learning was the tooling and the infrastructure. And so we were excited about the opportunity to try to build better tools here especially for scaling these applications and distributed computing. And so that's how we got started. We started working on Ray, trying to build open source tools to make it easy to build scalable applications, especially Python applications. And so we got our start there working on open source tools. This was at Berkeley. And we were running around trying to get our friends to use Ray, to try it out, to give us feedback. We were using it for our own projects. We started working with, started getting more users outside of Berkeley. And over time, as the project was really starting to take off, we thought, hey, we really want to solve this problem of trying to make distributed computing easy, trying to make it easy to build these scalable applications. And we were approaching the limits of what you can do with a handful of grad students in a research setting. And we wanted to really solve this problem, really make it a real thing. And that led us to start Anyscale, where we are also, we're actually continuing to develop Ray and trying to build, and also building the Anyscale platform, which is a managed Ray service. So essentially, the goal with Ray is to make it easy, for Ray to be the best way to develop distributed applications, to build these scalable applications. And Anyscale is aiming to be a platform that's the way to run Ray. Of course, I can say a lot more about that, but that's sort of how we got started.
And I just see from, my friends at Amazon, there's just like so much excitement around Ray and Anyscale. Like, I know we've got like an internal Slack channel that's just of like Ray interest, and there's just so much buzz of people sharing like, oh, hey, like, are you going to like the Ray Summit? And like a lot of people going together. So there's just a lot of community excitement that I see in the community for what it is that you guys are building.
Yeah. And one thing I want to add here is just, and maybe this may be clear to everybody, why is distributed computing important here? Why is distributed computing important for AI? One of the underlying trends that we've been seeing throughout the past number of years is the growing need for distributed computing, a growing need for building these scalable applications. And there are many reasons for this, many forces driving this trend. But one of them is the fact that AI applications are incredibly computationally intensive, right? To do AI, scaling is no longer really an option, it's a requirement. And, AI, is as it continues to permeate every industry, which is something we think will continue to happen. There's just a growing need from all corners for the ability to scale, and of course, as that's happening, all of these companies trying to succeed with AI end up needing to build infrastructure teams or hire experts in infrastructure to build all the scaffolding to scale and deploy these kinds of applications. And that's incredibly hard. It requires a lot of expertise. So one of our goals here with Ray and Anyscale is to make this stuff easy, right? Is to let people take advantage of, the power of the cloud, right? To build their applications, to scale their applications, but without needing every developer to become an expert in distributed systems and all of the lower level details required to do that.
That's just like music to, I think, a lot of people's ears listening right now, because I see so many startups where that's kind of a threshold that they reach at a certain point.
Right. You fast forward, however many years, 5 years, 10 years, everybody's doing AI, getting value out of it for their businesses. And what is that going to look like? Either every developer has become an expert in distributed systems and is, building all of this infrastructure and everything, or we found a way to make it easy. And I think that the first option is not a real option.
Yeah, I think I'd love to hear if you can, expand more a bit about the frustrations that you experienced as you were thinking really about building AI apps, and how that helped you think about what you wanted to see when you were building Anyscale.
Yeah, I think the frustration is that when you're developing, if you're writing a program on your laptop, like building an application that just runs on a single machine, you're primarily focusing on the logic of what you want the application to do, right? The machine learning logic, and for example. And when you're building a scalable application, is, say it's too slow to run on your laptop, so you need to scale across a cluster of machines, you still are developing the application logic, right? You're still saying you want your application to do, but that becomes a smaller and smaller fraction of the overall thing that you're building. And you have to think about other considerations, like how do I divide the work between all of the machines, right? How do I do that sort of scheduling and assign different tasks to different places? Or, what if a machine crashes? How do I handle machine failures? And it's not just crashes due to errors. It could be machines going away due to using preemptible instances, right? For cost reasons. How do I take advantage of preemptible instances and to make things cheaper? Or how do I scale elastically, right? How do I, if my workload is bursty, how do I scale up and down? Or if I need many different types of resources, GPUs, CPUs, other specialized accelerators, how do I take advantage of those in my application? Or how do I move data efficiently between machines? There are all these kinds of problems that you have to solve, and normally it's everybody is solving them over and over, right? It's you think about a distributed system like Spark or like TensorFlow, or another system like a system like Flink for streaming, or a system for models serving and deployment. All of these systems, they do the application logic, but they also solve all of the same distributed systems challenges. And so that's incredibly challenging. I think another challenge that we ran into is really flexibility. Okay, so there are a ton of great distributed systems out there for certain use cases, right? Like if you want to scale deep learning training, you've got systems like TensorFlow, right? If you want to scale you want to scale workloads like data processing, you've got Spark, right? And these are fantastic tools. But as soon as you go outside of these individual boxes or use cases, for example, maybe you want to build an application that does data processing and training together, right? And that's not that uncommon. Then you start to have questions like, well, Spark is good for part of that. TensorFlow is good for part of that. Am I going to glue them together? Am I going to build a new system? And you end up, what you end up wanting is really something like what you have on your laptop, which is a general purpose programming language like Python, and many more specialized libraries that are part of the Python ecosystem that you can just import and use together. And that's a little bit of what we're trying to create with Ray. Ray is super general. You can scale any workload on top of Ray. Training, the data loading and pre-processing, the deployment, the hyperparameter search, stream processing, graph processing, and so on. So the generality means that you can import, from the developer perspective, you can import these different scalable libraries, use them together, build out any other missing parts, and that gives developers flexibility to really build new things that just haven't, for new use cases that haven't been anticipated before.
Robert, I gotta say, like you're tackling so much already. I'm kind of curious, like, what is your think big aspiration for Anyscale and Ray going forward?
Yeah, I mean, it's a great question. We want to get to the point where developers only think about their application logic. That's it. If you want to, and that developers don't worry about infrastructure, they don't worry about distributed systems, they don't have to learn about, as much about what's going on under the hood there. And if you think about, there was a time when to build applications, everybody, it was writing them in assembly language, right? In a very low level, like machine language. And the best developers were people who could do all of these low level memory optimizations and things like that. And, everyone had to do it because it was just on the critical path for developing application. And of course that's going to limit, how many people can do it because it's hard. Now, today, nobody thinks about assembly language, or almost nobody. And that's great, right? It means that it's just totally off the critical path for developing applications, and it's really open to some people who can do it. Now today, if you want to do AI, or if you want to really build scalable applications, there's a lot of this infrastructure work and distributed systems work on the critical path for building your applications and doing AI. That's going to change. Like, we want to take all of that off of the critical path. We want it to go the same way as assembly language, where we get to the point where developers just never think about this stuff. It's still happening under the hood, but you want developers to really focus on the problem they're trying to solve, the application that they're building. And just to give you an example, we think that AI will continue to permeate every industry, but a lot of the applications that you'll see are not just machine learning or AI in isolation, where somebody is just training a machine learning model or just deploying a machine learning model. I think you'll see AI increasingly integrated into products and applications that are much more complex and have many moving pieces. And just to give you an example, suppose you want to build like a search engine, right? Like Google search or something. Think about the different pieces. There's web crawling, right? You have to crawl the pages. There's data processing. You have to process the pages and extract the keywords, build the search indices. There's machine learning training because you want to rank the pages. There's going to be model deployment and other kinds of serving, because to respond to users, respond to queries. All of these different things have to be scalable. And today, building all of this is a tremendous infrastructure lift. But we'd like to get to the point where, ideally with Ray and Anyscale, where developers can just, you import a library for web crawling, a library for training and the data processing and serving, and these all scalable libraries on top of Ray. It just feels like you're writing a simple Python script or application, and you can build this kind of scalable application and ship it in a very short period of time, say a day or two. And that would be fantastic. I think we really want to enable people to build far more than they can build today.
I think that's so exciting. I think there's a lot of people who are just, after this, really looking forward to just getting started right away. So what's the best way for people to, really try out Ray, try out Anyscale, get in touch?
Yeah, so if you are looking around at, say, there's many different kinds of use cases, and of course part of what I'm saying about Ray is that we value is the generality and what you can do with this whole ecosystem. That said, one of the most common use cases is if you are at a company and you're looking around to build your next generation machine learning infrastructure. Ray is an increasingly common choice there. So if you're at Uber, right, you're doing your deep learning training, you're training your PyTorch or tensor models or your XGBoost models, there's a good chance you're doing it on top of Ray. Same with if you're at Shopify, right? If you are doing scikit-learn or PyTorch or Tempo, or XGBoost, like these are all, these are happening on top of Ray. And it's, of course, that's the training. There's the hyperparameter search. There's the data preprocessing. Other companies like OpenAI training their largest models on top of Ray. And so, if you're asking yourself, what is the right compute infrastructure for doing machine learning at my company? I'd encourage you to take a look at Ray and see what other companies are doing with Ray. There's the fact that it handles training and certain use cases like that today, as well as the future-proof aspect where it handles all of these different, other kinds of workloads going forward. And if you're looking for a managed service to run Ray, Anyscale is a great choice. Where you can get in touch with us and try it out. You can run it on AWS and have a really simplified way to operate and manage the Ray clusters and jobs. And so, what's the best way to get in touch? We have a lot of the Ray community is on Slack. We have a Slack. If you go to there's the Slack workspace. We have a forum online where people are asking questions about Ray, and we're helping people out. And actually, another really great opportunity in August, we have a Ray Summit. It'll be in person in San Francisco, and a lot of the Ray community will be there. People will be talking about their use cases, how they're using Ray to solve problems ranging from building better recommendation systems, to training use cases, to like manufacturing and industrial scheduling problems, and to gaming companies. There's a huge variety of different kinds of use cases that'll be highlighted there. So that's another great opportunity to really see how people are using Ray.
Yeah, wow, this is so exciting. I think a lot of people are just gonna, get started, and I'm definitely excited to see what it is that people actually, start building. So, Robert, thank you so much for taking the time to be here with us today and tell us more about Ray and Anyscale.
Yeah, we really appreciate it, Robert. Take care, everybody. Thanks for joining us on AWS On Air.